Okay, it's a pleasure to be here. Thanks for the invitation to speak and for organizing this great event. So I'm going to talk about sort of 3 years of my life that had to do with several retractions. So my work on superconductivity is currently supported by the National Science Foundation DEMREF program. So again, there have been thus far about 5 retractions that include 2 PRLs and 2 natures. 4 of these I was somehow involved in, and one of them as a co-author. So I've sort of seen this thing from both sides, and I'm going to talk about my view from both sides of these kinds of situations. In 3 of these, I was sort of a person expressing concerns about the works. So the entire story here has been made a lot more clear by the recent appearance of this investigation report from the University of Rochester that looked into several papers from the work of Ranga Dias at the University of Rochester. And the story is basically that there were concerns for a long time. UR carried out 3 inquiries that found no cause for concern. And then finally, they were asked by the NSF to carry out a full investigation. And this report, which is 120-some pages, is very, very thorough, very complete, and really a tremendous amount of work by the authors of this, very careful work. And the report became public through a lawsuit, and you can read about this in this article from Dan Garisto and reach the article as well through a link in this article. Reach the report through a link in this article. Okay, so basically, the report looks at 16 different allegations and found by a preponderance of evidence that Dias's conduct constitutes research misconduct. And they also concluded that the other members of the respondent, that's Dias, his laboratory, were basically the victims in the situation. Okay, so let me talk about a distinction between primary or raw data and other types of data, because this is going to figure prominently in several of the stories that I tell here. So primary data for an experimentalist is often, although not always, some kind of comma-separated file, just a text file, basically. It probably contains several additional columns of diagnostic data. So you might have the resistance of a thermometer, along with the temperature that is extracted from that resistance. Ideally, the timestamp should be preserved, and you might have lots of bad data in there. That's totally irrelevant. So maybe the student forgot to shut down the measurement program and it sat there for 8 hours collecting data at fixed temperature. It could contain a header with lots of additional metadata. What are things that are not primary data? So often, although not always, it's going to be an Excel file. Most software that we use doesn't make Excel files. Could be an origin file or some other plotting software. Timestamps are different. Maybe you've computed additional values after the measurement, or you've even overwritten the original values. And it could be, for example, a single file that accumulates data from several measurements. So maybe an Excel file that has data from several different pressure runs. Okay, so with that distinction in mind, let me kind of jump into the story. The story begins with this publication of a paper reporting room temperature superconductivity in a carbonaceous sulfur hydride in 2020. And the paper showed electrical resistance measurements dropping to 0, field dependence, and AC magnetic susceptibility. And my former colleague, Matthew Debesai, along with Ranga Dias, was a co-author. And he, according to the contributions, was involved in the susceptibility measurements, which were the same type of measurements that I did as a graduate student in the same lab. And so I looked at this and was very excited. It looked quite convincing. Jorge Hirsch looked at this and was not convinced and began expressing concerns about the paper. And he started talking to me about the susceptibility data because he knew I knew how to do those measurements. And eventually he came to point out that in an old paper from 2009, data we had taken on europium looked very much like the raw data from the CSH paper. So he looked at these two plots and looked at the common author, Matthew Debussy, and concluded that perhaps there was some kind of misconduct and insinuated that in a paper he published on the archive. And I was quite upset because I felt like this was not sufficient evidence. In the end, he turned out to be right, that there was a problem here. Okay, so this was sort of the last thing I worked on as a PhD student. I had left for San Diego, Takahiro Matsuoka had gone back to Japan, and Matthew Debussy collected these data, which were the data that allowed the paper to be published in PRL. Okay, so let me tell you a little bit about this paper, which was eventually retracted. So we told Hirsch that Matthew Debussy had the data, and he did not share the data when Hirsch requested it. Our PI, Jim Schilling, had retired at that point, closed down the lab. And so Matthew's not sharing the data. Takahiro and I don't have the data. Eventually, Hirsch starts sending very forceful emails asking for the data, at which point Schilling is able to locate the data with the help of another student who just happened to hang on to the drive after the lab closed down. Very fortunate. So I was sent the data. It included about 65 raw data files, an origin lab, and some notebook scans. And I was all ready to prove Hirsch wrong, that there was no problem with the data. And unfortunately, that's not what I found. So here's one example of the analysis I did, which took a lot of time and was very comprehensive. So blue is what was published in PRL, and orange is what the data should have looked like. And so now I figured out the exact set of steps that were followed to transform one data set into the other. So first, the data was shifted a bit, that's okay, but then the data at low temperature was shifted by a different amount. And then somehow this business in the middle was deleted. And I wasn't quite sure how that was deleted until I wrote a code that basically compared every piece of every data file to this missing data. And I found that Debussy had just copied some noise from this region and pasted it over there. So clear misconduct. Discovering this really required the raw data. Without the raw data, all we had was the blue. You wouldn't know what was the problem. Not only did it require the raw data, but to reconstruct the exact set of steps, I also needed to use this awk script that I had written to do background subtraction some 14 years earlier. So not only the data, but the methods and the code are very important for really disentangling these things. Okay, so the paper was retracted. It contained this somewhat vague, although correct statement that the data were not accurately reported. This was the strongest statement that we could get Debussy to agree to. We were encouraged to come up with a retraction that all the authors agreed to, and that's what we did. So from the first time Jorge requested the data to the actual retraction of the paper, if my math is correct, was 13 months. If I can find fault with my actions in this situation, it's that I didn't demand an expression of concern before the retraction, okay? I am proud of the retraction in the sense that it's very definitive. So we also tried to reproduce the measurement and found that it didn't reproduce. So there's no question that this result doesn't stand up. Okay, so with the europium retraction having occurred, now there was an additional push for Diaz to submit the raw data for the CSH paper, which he hadn't shared. And eventually it was shared in the form of, tens and tens of pages of these images of data. So you had to extract this with optical character recognition. This is not raw data. Hirsch and van der Marel did an analysis of this, and they found that the data, the published data, this green curve, could be decomposed into kind of a digitized part, which looks like experimental data, and what turned out to be a cubic spline. This in and of itself doesn't prove a problem. It could be that the background was fit with a spline and then the spline was subtracted. But eventually it was proven that the raw data had to be manipulated. And that was proved in a very comprehensive and elegant and thorough way in this archive paper from van der Marel and Hirsch. To kind of put my spin on it, here is temperature difference data. Almost all the data I'm showing you is voltage versus temperature. So these are voltage differences versus temperature in the region of the superconducting transition. And the raw data, or what they claimed was the raw data, is orange. And they claimed they subtracted this sort of random background. When you subtract the background from the raw data, you wind up with the published data, which is sort of perfectly digitized in these increments of 0.16 nanovolts, which is very difficult to understand. On the other hand, if the raw data is the published data plus the background, this is easy to understand. So the raw data is not raw data. So the paper was retracted, but after the retraction, the authors were still claiming that the resistance data was good. And by the time this quote appeared, I had asked for the electrical resistance data. I had expressed some concerns about the resistance data and didn't receive it. Even though I didn't receive it, I was able to extract the data by sort of analyzing the code in the PDF file, which the figure had been included in vector graphics. So you can read about that in this archive post. And what I found, so here is what Hirsch and van der Marel found about the unusual structure of the published data. For the resistance data, I found something very similar. It could be decomposed into a smooth curve and a digitized part. So this was the published data, which is not what you expect to find for measured data that's been digitized. Okay. And so they had explained this as being due to background subtraction. But of course, resistance data shouldn't have a background subtraction, especially if you're trying to prove the resistance is zero. So what does the investigation report say? It basically says that the data wasn't collected at University of Rochester or UNLV, according to any of the members. Raw data sets were never provided. So it's just completely unclear where the data came from, basically. And finally, that the investigation committee basically agreed with the conclusions of van der Marel and Hirsch. Okay, so having established this method for extracting data from papers, I started looking at some other papers, including this 2021 PRL by Diaz, and I noticed that some curves looked very similar to some data sets from his dissertation. And so I extracted the data, and when I plotted them at low temperature, this is just one of several curves that agreed that I found. They look very, very similar. This seemed hard to imagine it could be a coincidence. So I sent in a letter to all the co-authors of the paper and the editors of PRL. Simon Kimber, who was one of the co-authors, took a look at this. We spoke, and he immediately called for a retraction of the paper within days, maybe 2 days, maybe 1 day. So what did the investigation find? So none of Diaz's co-authors collected those 3 data sets that were called into question. So the published data didn't originate from any experimental measurement. And they said the manipulation is blatant and clearly constitutes intentional data fabrication or falsification. And if you wonder if this is true, you can look at this figure from the investigation report. So Diaz had sent this data from his dissertation to a colleague when I submitted my concern, and he had sent the data on manganese sulfide to a student, I believe, around the time the paper was being published. And if you look at the temperatures, they are identical to many digits. So this is clearly the same data. One material being misrepresented as another. Okay, so around the time this was all happening, Diaz's group published another paper, even more spectacular, claiming room temperature superconductivity at almost ambient pressure, at least for a high pressure physicist. So 1 GPa, 10 kilobar room temperature. And there was a lot of compelling looking data in this paper at first glance. There was zero resistance, there was even Meissner effect, there was specific heat. I think those of us who had been following the story had this very strange state of mind at the time. You know, is it possible that all of this misconduct happened and still this spectacular discovery was really made? It was a strange time. So unlike the CSH situation, source data were included. So the source data wasn't raw data, but it was basically the data that was shown in the plots. And so this allowed the problems to be uncovered quickly. There were a lot of things circulating online, people pointing out oddities in the paper. Brad Ramshaw reached out and we decided to submit this and other concerns that we had found officially to Nature. And so one question we asked was anything subtracted from the raw resistance data? A very straightforward question. Brad had noticed this kind of unusual structure to some of the resistance data. So each color here is a fixed temperature interval because there was a finite resolution to the temperature data. And if you plot versus index, which is sort of like plotting versus time, the data jumps around in this odd way. It's hard to understand how that could occur in an actual measurement. So what responses did we get? We got from Ranga Diaz, there are no offset voltages subtracted. In the instrument, you have an option to pick the offset voltage automatically. It's the instrument, not we doing something manually. Kind of an internally inconsistent. We didn't subtract anything, we did subtract something. And then we want to clarify that there's no background subtraction. So they're coming down hard. There was nothing subtracted from this data. Okay, we also asked if we could see the raw.dat file produced by the quantum design PPMS, right? So these instruments, if you don't know, they produce data files that have a lot of extra columns in them with all kinds of diagnostic data. There's an extensive header. My reasoning was that it would be very difficult to convincingly falsify all of that data. Much easier to falsify just a 2-column data with temperature versus magnetization. So I asked repeatedly for that data, and what response did we get? Was nothing, right? We didn't get the data at all. These were just 2 of numerous different things we submitted, but I'm trying to keep the story concise. So what did the investigation report find? Well, the low temperature data for resistance was altered to present the appearance of 0 resistance. And in the magnetization data, some kind of additional undisclosed background subtraction flipped the sign of the signal to give the appearance of a Meissner effect. Okay, and so here's the resistance data. Here's what was published. I don't have time to talk about it now, but I can show that basically a cubic spline was subtracted from this to get to here. So another interesting fact is that the student co-authors were not emailed by Nature until after Diaz had replied to our concern. This was despite sort of repeatedly asking that the other authors be copied in on the correspondence. Okay, so let me just spend my last couple minutes kind of telling you some of my takeaways, which are meant to be sort of constructive and not critical. Okay, so I admire everybody I've worked with in this situation is doing the best that they can within the constraints that they're facing. So let me kind of talk about first journals. To me, I think it's very clear that when a journal receives an expression of concern, either formal or informal, all of the authors must be contacted or have access to that correspondence. All of the authors are at risk of the reputational harm. They deserve to be kept in the loop. The journals make us fill in everybody's email address now, so they have the email addresses. Let's please make sure that everybody gets included in that correspondence. And then, having been on the side where I was facing potential misconduct in the ranks of a group that I worked with, it would be really helpful if the journals could be a little more frank about what the different possibilities are in terms of moving towards a retraction. There's kind of a sense that it's too difficult to talk about, and so the minimal number of words are said. So I would have loved to have kind of somebody lay out to me the different scenarios that we could follow to reach a retraction. Okay, now for the concerned scientist, I mean, this is somebody who thinks they've found a problem in a piece of work. First, asking questions is definitely good. But public accusations or insinuations even of fraud or misconduct shouldn't be leveled until you have really unassailable evidence. And this is pragmatic, right? If you start throwing around accusations on weak evidence, people will stop listening to you, and it will wind up taking longer to reach the point where the work is retracted or corrected. Okay, now for researchers, I think even seemingly unjustified concerns have to be tackled with a scientific mindset, and the issues should be looked at carefully. That's part of what I admire about how Simon Kimber reacted to this situation. Now, my last two items are things that I hope will kind of spur some further conversation. So I think that before a paper is published, I think we all take for granted that all of the co-authors should be contacted and given a copy of the paper before it's submitted with sufficient time to look at it. I think we should also try to establish a culture where the co-authors are given the primary or raw data, access to that data, so that they have a chance to look at it before the paper is submitted, and so that they have it after the paper is submitted. Last item, which might be controversial, is making primary data public should become a standard part of our work as scientists. And in my experience, there are two views of this. There are people who take it for granted that this is completely obvious and true, that this should be done. And there are people who feel that this could be too much work. It could cause problems with people asking questions about data that they don't fully understand. But I think as scientists, we should err on the side of openness, should make that data available. And so I hope that these last two items are things that we can discuss further about trying to establish a culture that achieves these goals. So with that, I'll stop and thank you all.
Thank you very much, James. We can accept one question. Igor.
I have a longer comment, but I probably don't have permission to field it, so I'll save it to our discussion. But now my short question. So you cited two archive papers on which one you are a co-author, the other you're probably very well aware of the history behind. Was there any attempt to actually publish that in a high-profile journal? And if yes, what happened? If no, why not?
I tried to put the, now you're going to forgive me, I'm blanking on the name of the, is it SciPost? Yeah, yes. I tried to submit it there, and it was viewed as a comment on a retracted work, and so they didn't want to accept it. So I didn't try to publish it elsewhere.